Okay, let's check this guy out. So we got three resistors with values of 5 ohms, 10 ohms, and 15 ohms are connected in series. All right, so let's look at the whole problem here. This would be a nice like little test question to answer all three of these at uh, at what rate is the energy? Oh, I love that. At what rate is the energy? So here we go. Let's just take a look at this. So I've got 5, 10, and 15, and they're in series. Okay, total resistance. Now, so for this problem, I've got R1 is equal to 5 ohms, R2 is equal to 10 ohms, R3 is equal to 15 ohms. I think they left it in 3 sig figs 4. So R in series, piece of cake. 5 plus 10 plus 15. That would be 30. I'm trying to hurry here because I got to go. If you notice, it's 1:43. I've got to be teaching you in 17 minutes, so I'm not going to get through this entire lesson, but we'll get close. All right. So now, so that's what it is in series. What's their next question now? What else do they say? What is the current in each resistor? Oh, let's draw the picture and look at the current real quick. Okay, so here we got this little 5 ohm, bigger 10 ohm, much bigger 15 ohm resistor, and they were hooked up to a 9-volt battery, I think. All right, so 5, 10, 15. All right, so we want to know the current that's going through each one of these. The current's the same because the current coming out of here, boom, I. Notice he doesn't break up anywhere. So this is I, and this is I. It's going through the same. So let's take the total resistance, which is 30 ohms. And then I know that V total is equal to I times R total. Because the I stays the same all the way through, so I know that 9 volts is equal to I times 30. So that becomes 9 over 30, which is what? 3 tenths, 0.3? 0.3 amps. Well, that's nice. I hope I did that right. Is that 3 over 10? Yeah, 0.3 amps. Okay, now, what's the next question that they asked? At what is the current in each resistor? Well, the current's going to be the same in each one of them. At what rate is energy delivered to the 15 ohm capacitor? What's the power? What's the rate of energy? Power, rate of energy. That's one of the key things I wanted you to get from this. Rate of energy. That's power, people. Power to the people is power. Okay? So P equals V squared over R. I don't know what the voltage is. I can figure out what the voltage is because I can go 30 times, well, 0.3 times 15 is 4.5. So the voltage going through here is 4.5 because that equals I, which is 0.3 times 15. So that should be 4.5 volts. All right, so I can go 4.5 squared over 30 over 15. I could have also done, and I'll do it the other way too, just to drive home the point, and then we'll finish this one. Then we'll be done with this slide. So I got 4.5 squared divided by 15, 1.35 watts. That's how much power is delivered to that one. Now then, I could have done P equals IV too. That might have been a little bit. That might have been a little bit better, where I got P. Well, I could have done 0.3 times 4.5. Look what I get there. I get 1.35 that way. And I could have done P, which is the numbers I actually had, was I squared times R. And if I'd have done 0.3 squared times 15, just to let you know, 0.3 squared times 15, I still get the 1.35 watts. Again, it's one of those things. The beauty of physics is how flexible it is, but it's also what adds to the confusion. Out here, and I'll finish these up after our lecture that we're going to have in about 10 minutes. See you in 10.